Question number 3. Define magnetic field. So what is a magnetic field? So definition of magnetic field is a region where the magnetic force FB exists. So meaning let's say you have the current flow in the wire, and this is a magnetic field produced by the wire. So this is the area of the magnetic field. Number 3.2, sketch magnetic field lines surrounding in the current carrying loop. So this is the, let's say this is the loop, and the current flow, this is the direction of the current flow. So if you have a right hand, let's say the right hand here, this is your finger and this is your thumb, right? So direction of the, this is direction of the current. So the direction of the magnetic field is your finger here, direction is a right. So this is direction of the B, right? So the same process here, the direction of the magnetic field here is a, and sorry, this is not right. This is here, so direction here. So if you use your right hand here, direction your thumb to downward, so meaning the direction of the B here, right? And the same process here, use your right hand, so this is direction of the B. So if you draw the in the loop here, this is the direction of the B, right? And this is direction of the B. Or if you just straight line here, this is direction. Okay, this is how you can draw the magnetic field surrounding the current carrying loop. Next question, the figure show positive charge. This is a positive charge pass through the velocity selector where the magnetic field is 100 millitesla perpendicular to the electric field 1 kilovolt per meter, and the magnetic field of equal magnetic is used to deflect the ion in the circular part. So meaning the magnetic P here is equal to P here, a circular part here, this diameter is 15 mm. The deflection chamber, so this deflection chamber, calculate the number 1 is velocity of the ion. So velocity of the ion, so at the velocity selector, the value, if the positive charge enter to the regions B and electric field E, the positive charge is to moving downward by the electric force or Fe. And the same, we have B at the region here, meaning the positive charge here also have a magnetic force Fb. So meaning in the regions, positive charge have two force X on it. The first force is a magnetic force and the second force is a Fe. So Fe is equal to charge electron time magnetic electric field E, and the magnetic force X on the positive charge is a QVB. So the negative charge direction Fe to downward, because this is positive and this is negative plate, so many direction Fe to downward, and the Fp to upward, because if you use the right left hand, the direction of the B into the page, and direction of the V, right, to the right, so the force is upward. But the velocity of the object is a constant velocity, meaning the force, upward force, is equal to downward force. FB is equal to FE. FB is equal to QVB, and FE is a QE. So you can cancel here. So now if you calculate the speed of the positive charge here is a E divided by B. The value of the E is equal to 1 kilo. This is 1 kilo is times 10 power of 3, and the B is 1 milli is 100, milli is minus 3. So you can find the value of the speed here is 1 exponent 4 meter per second. This is speed of particle. Now when the positive particle enter to the deflection chamber here, so direction of the particle moving in the semicircular parts, where the diameter of the semicircular part is 15 mm. So the force acts on the positive or particle here is a magnetic force, or FB. So FB, the force acts on the positive particle, is given by the equation QVB. And the QVB force acts on the positive charge that can make the positive charge moving in the circular part. So this is circular part. This is, you can refer to the centripetal force, or FC is equal to mv square divided by r. Meaning here you have a combination magnetic force and centripetal force. But this is the value for FB and FC is equal value, because the magnetic force can make the particle positive moving in the circular part, meaning the QVB is equal to mv square divided by r. So now you can find the value of the question asks you to calculate the mass. So what is the mass? So the mass here, so the mass M is equal to QV mass M is equal to QBR divided by V, right? Because this is I can cancel V here, right? And put in the value of the Q is a charge proton is 16 exponent minus 19, and the speed here is come from the answer number 1. The speed here, this is the speed of the particle charge, is 1 exponent 4 meter per second. This is the V, right? And the B is equal to, this is the same value at the B here, 100 millitesla. Milli is minus 3, and the radius R is given by the 15 mn, meaning 15 is a 15 convert to the meter is minus 3. So you can find the value of M here is equal to the mass of iron is equal to 2.4 exponent minus 26 kilogram. So meaning you can find the value of the mass of the iron by use the combination of two equations here, magnetic force and the centripetal force, after the particle positive charge enter to the deflection chamber. Next question is what is